Hello everyone. Today we are going to solve paper 2 of March 2026, paper 22. As you know, in Coordinated Sciences, the physics questions starting from question 28. The first question we have here in the exam, question 28, an object is accelerating. So before solving the question, you should know what does it mean acceleration. So acceleration is the change in velocity per time. So if there is a change in velocity, it means yes, we have acceleration. So when we talk about a change in velocity, the velocity has two things. It has a magnitude, the speed itself, and it has the direction. So if there is a change in speed, there is acceleration. If there is a change as well in direction, it can be also acceleration. So because of this, before solving this question, and it's easy and direct, but you should know that you may have a question and there is no change in speed, but there is a change in the direction. In this case, yes, there is acceleration. And this happens if you have circular movement. If you have a satellite, let's say, and orbiting the Earth, in this case, if the speed is constant, but the direction is changing, in this case, also we have an acceleration. So take care about this important note before solving this question, because you may have a similar question. Okay, let's see now which statement describes the motion of the object. Here, it's at rest. Okay, if you talk about rest, it means zero velocity, zero change, okay? No change even in direction, so no acceleration. So it's not A. And then it's moving at a constant speed in a straight line. So it's moving at a straight line, the same direction, constant speed, no change in speed or direction. So this one, no acceleration. The acceleration here actually is zero. And then it's moving at a constant velocity. At a constant velocity. If it's constant velocity, again, it's no change in this velocity, so it's a zero acceleration. Okay, so it's not C. Then the answer is, of course, D. It's moving with increasing velocity. Increasing velocity. So if it's increasing velocity, we call this one acceleration. And also you should know that we have deceleration when it's decreasing in the velocity. Okay, so the answer is D. Okay, so take care about this and take care again about that acceleration. It's not only change in speed, but also change in direction. Because both of them, the direction and the speed, they are the velocity. Okay? And before moving to the next question, because this is not just solving 13 questions, this is about full revision. So before going to the exam, you should know the distance time graph and the velocity time graph. If you have distance time graph, so the gradient is the speed, okay? And this one you have like a straight line. This is the gradient and it's constant speed. But when you have flat line, okay, the flat line, this is like not moving at all, okay? This is the stationary mode, like no movement at rest, okay? So this is in distance time graph. And if it's speed time graph or velocity time graph, the gradient in this case will be the acceleration. And if you want to find the area under graph, or if you want to find the distance will be the area under graph. So don't please forget this. Velocity time graph, it's the gradient in the acceleration. And if they ask you to find the distance, you have to find the area under graph, okay? And most likely you have triangle and rectangle, not more than this. Okay, so don't forget this, please. because this is very important, because you may have like 4 graphs and they ask you which one has a constant speed, which one has constant acceleration, and so on. So try to practice this type of questions as well. Okay? So again, to test you, if a car travels in a circle at a constant speed, or if there is a satellite travels or orbits the Earth at a constant speed, is this acceleration or not? Yes, it's acceleration because the direction is changing. Okay, direction changing, it means velocity change, it means there is acceleration. Okay. Next question is, a system uses a 250 watts electric motor. So this is the power, okay? In this case, it's very important usually to know the units, because what is the unit of power? So the input power, what we have, okay, so this is the input power, is the 250 watts. Okay, they said that this input will lift a 50 newtons load through a height of 4 meters in 3 seconds. Okay, this will lead to what? This will lead to, you have to know the formula. Okay, moving an object, it means this is work. Okay, and work should be F times D. Okay, the force times the distance. So if you talk about the force is 50 newtons, times the height is 4, and this will give you 200. And from this one, you can find the power, right? So you know that the power is the work per time, okay, or the energy per time. So the work is 200, divide that time, which is 3. So this is our useful output. Okay, so this is useful output. Okay. There is a note here, take care, like you may get confused when you see, 4 meters in 3 seconds, you may think this is a speed. Okay. No, here we are talking about power output. Okay. So this is the useful power output, and this is the input. So how to find the efficiency? So don't forget that we have the efficiency formula. So efficiency, okay, equals to the useful output, which is this 200 over 3, divided by the input, okay, which is 250, and then multiply by 100. The answer should be like 26.7, which approximately 27%. Okay, so the answer is A. Okay, so this will lead us to another important note, that you should know all formulas. You should know them very well, and you should write them in a triangle to make it easy for yourself. So you should know the formula for work, the formula for the power, the formula for efficiency. Okay? And to not get confused, for example, if you have formula like this power, make a triangle for yourself. By the way, you may use your question paper to solve there. Don't just mentally solve, because most likely you will make some errors, some mistakes right there in the question paper. Whatever you want to like, it will not be graded there. And then shade the right answer in the answer sheet. And remember, please, that the answer sheet you have to shade in pencil. Okay, so here I can, for example, I can say that the power is the work, okay, over time. So when you want to find the power, is work over time. If you want the time, is work over power. Okay, So draw triangles for yourself to make it easy and to decrease mistakes. Okay. Next one, a chair of weight 40 newtons rests on 4 legs. Take care here, 4 legs. Okay. Has an area of contact with the floor of 10 centimeters squared. So each leg, okay, 10 centimeters squared. Okay, so now you have 4 legs. So take care when you find the area. Okay, so let's write. What is the pressure on the floor due to the chair? The pressure again, the force over area. Okay, so the pressure S, force over area. The force is 40 newtons. Okay, look, I wrote the unit here. I'm writing usually the units to compare my units with the units in the answer. Okay, to not have a problem with units. And usually this is a big mistake in exams. The some students, they don't care about units, so they have different answer at the end. Okay, and you know in multiple choice it's correct or incorrect. So over area, the area here is of 4 legs. So you'll not divide by 10, you will divide by 10 times 4 because it's 4 legs. Okay? And this is centimeters squared. So 40 over 40, which is 1, and the unit is Newton per centimeters squared. So do you have here 1 Newton per centimeters squared? Yes, this one. So the answer is A. Look, the units are the same, because if the unit not the same, I have to change or to convert the unit. Okay? So take care, please, about this, and don't forget that the legs, like, okay. Next one, if we move to question 31. Oh, now we move to thermal physics. Okay, in question 31, a gas is stored in a sealed container. The particles of the gas exerts a pressure on the container walls. Okay, so what causes this pressure? As you know, guys, that the particles inside, they are collide with each other, yes. But what will make pressure on walls? They are talking about walls that those particles are hitting the wall. Okay? So let's see which one here is talking about the particles collide with the walls. So the answer is C. Particles collide with the container walls. So if you have pressure or force over area, this will create a pressure. Okay? This is connected to the previous question. Okay? By the way, this will lead us to something you should know very well. That the unit of pressure here, look, they said Newton per centimeter squared. Okay, they didn't say Pascal. Why? Because the Pascal is Newton per meters squared. Okay, so take care about this. That the unit of pressure is Newton per meter squared or Pascal, but Newton per centimeter squared, it's not Pascal, okay? So don't forget the unit as well. Now, question 32, okay? And by the way, before moving to question 32, let's talk more about this pressure inside containers. So remember usually that if you have more particles, means you have higher temperature, okay? And if you have less volume, it means that they collide more collisions, and it means high pressure. Okay, so don't forget this information. Okay, and Also, by the way, before moving from here, you should know also Kelvin, 0 Kelvin, okay? That 0 Kelvin, okay, it should be, or we call it 0 Kelvin, or we call it the absolute, okay, zero, okay, it's like that. So this one, which equals to negative 273 Celsius. So take care about that, about 0 Kelvin, okay? Because you may have something like that, okay? So if you have any Kelvin degree, it means the Celsius degree what you have plus 273, okay? Again, increasing temperature. What will happen if you increase temperature? Means particles, they will have more kinetic energy. So particles move faster, and they will more collisions and high pressure. Okay, if you have like a fixed or constant volume. Okay. Question 32. Question 32, over a period of time, it's observed that the temperature of Earth increases slightly. Which statement about the Earth explains this observation? Okay, so here they are talking about the radiation. Is it more or less absorbed or emitted? So think about it, it's like if you have a bank account. If you spend more than you earn, so your balance drops, right? And if you receive more than you spend, so your balance, okay, will be increased. You have more money. It's the same. If temperature is rising, so an energy input, it means energy input. It will be more the energy output, or you can say that more. If more radiation is absorbed than emitted, so this will increase the temperature. Okay. So if you look at this one, no radiation is absorbed or emitted. Okay, we are talking here about the temperature is increasing. So if no radiation absorbed or emitted, so it means no change, right? But it's increasing, so it's not a. Here, more radiation is absorbed than emitted. Yes, actually, this is the correct answer. Okay, more radiation is absorbed. Okay, so the energy what we have inside is more than the energy what goes outside. Okay, so the answer is B. Okay, so also you have to, since we are talking about this question, you should have information about the thermal radiation, greenhouse effect. Okay, that you should know that all objects emit infrared radiation. Okay, so of course, if it's hotter objects emit more, and yeah, this will lead us to another point. Also, if you have dark matte or dark dull surface, they are best observer, and at the same time they are the best emitters. If you have white shiny surfaces, they are poor observers, but also they are good reflectors. Okay, so take care about this, because you may have objects in different colors like white and black, and one shiny and one dull, and they ask you to compare which one has like more reflection or more observer and so on, this type of questions. Okay, so they may ask you, for example, they may give you like vacuum flask, and they ask you which one is kind of like good material to use inside or to use outside. Of course, if from inside of the vacuum flask, it should be like shiny surface can be poor emitters. Okay. Next question. Radio transmitter emits radio waves with a frequency. So we have here the frequency. We have F. Okay. So the most suitable real for this frequency is 1/4 of the wavelength. So here, take care that they said 1/4 of the wavelength. The speed of waves, they give you that the speed of wave, this is v. Okay, so you have f and v, speed, and they give you the speed. And by the way, they may not give you the speed sometimes, because the speed of radio waves or the speed of all electromagnetic spectrum is the same. It's 3 × 10⁸. This is the speed in vacuum, okay? Meters per second. So we are talking now about the most suitable length. So you have to recall the formula. The formula of V is F times lambda. And you know that V is the speed, F the frequency, and lambda is the wavelength. The speed is meters per second, so frequency should be, or wavelength, it's in meters, so frequency should be in hertz. Okay. Now the question is find which one length. We need to find lambda. So now we know when we draw the triangle that it will be V over F. So draw the triangle, please, to decrease errors. So sometimes you may think it's F over V. So in this case, you can say that V, the speed is 3 × 10⁸ meters per second, divided by F, the frequency, which is 1.25 × 10⁸. Okay, I'll use my calculator to see. 3 × 10⁸ divided by, don't forget the brackets, please, when you use scientific calculator. 1.25. It's better to use the fraction if you have fraction in your calculator. 1.25 times 10⁸. Oh, both of them to the 10⁸. That's good. You can cancel them. So you can make that 3 over 1.25. Okay, so lambda here should be 2.4 meters. Okay, so take care about the common mistake that you will say, Mr. Now it's 2.4 meters. This is the answer. No. You have to read the question very well. In the question, they said that the most suitable one for this is 1/4 of the wavelength. So you have to multiply your answer by 1/4, like to divide this 2.4 by 4. So the answer should be 0.6, like this, 2.4 times 1/4, okay? So it should be that 0.6 meters. So the answer should be B. Look, read the question, please, very well. Okay, and this will lead us to something else, please. Try to practice. Look, I will go to other exams to show you some examples. I will not solve them, but I will show you what examples you need to practice about waves. Look, here waves. No, I will show you waves. Waves, it was another exam. Waves. Look, so it will lead also that, please, you should know more about waves. So, for example, if you have something like that, this actually is talking about voltage, but I mean, like, you should practice some multiple choice questions about waves, about amplitude, about frequency, about wavelength, to see which one has more frequency, which one has more amplitude. Hopefully, I'll find example here for you. Yeah, like this one. This type of questions also, okay? So don't depend only on the 13 questions we are solving. So if you have something like this one, so which one has higher amplitude? Which one has higher frequency? So if you look at them in this question, for example, that both of them here, they have the same amplitude. Since they have the same amplitude, it means they have the same loudness. So it's not related to the sound is if it's loud or not. So it's not B or D. So which one is correct here? The frequency here is more, as you see. Here frequency is more. Here's frequency is less. So if the frequency is related to what? It's related to the pitch, if it's high or lower or low. So here they said sound P. Okay, so the sound P here has lower pitch. So the answer is A. C. This is lower. Okay, so again, try to practice also questions about waves. Okay, to know the frequency and the amplitude. Okay, guys, and also the types of waves, if it's transverse or longitudinal. So they can ask you about refraction or compressions. Okay. Not only this one, also you should know refraction and to find the incident angle of incidence or angle of refraction, how to find n, the refractive index, and what else? Like, yeah, those type of questions. Okay, so for example, not only also reflection, refraction, we have also diffraction. So you should know this one as well in multiple choice. Okay, so let's back to our exam. 34, a glass block on a lab bench is surrounding by air. Light travels in the glass block and reaches the edge of the block. The angle of incidence at the edge is much smaller. So I is much smaller than the critical angle. Okay, what happens to the light? So in this case, you have to remember the three cases what you have. That if I, okay, is less than alpha, so it means that most of the light should refract. Okay, so this one, most of light should refract. But if I is less, if I is greater than alpha, in this one, it should be what? It should be total internal reflection. So remember, like if the angle of incidence greater than alpha, so it means total internal reflection. And by the way, total internal reflection happens not only when I greater than alpha, but also when you are moving from denser material or medium to less dense medium. Okay? The second condition. Remember this one because it comes also in multiple choice. So in if they are equal, okay, in this case, it's critical angle equals to the angle of incidence. This one, we will have 90 degrees refraction. So the refraction angle will be 90 degrees. It will be on the boundary. So which case we are talking about here? We are talking about the first case. We're talking about this one, that it's less. So most will refract. So the first one, all of the light merge into the air. And again, remember that the idea of like all lights, we don't have like all light will. So of course not all of light merges into the air. This one is incorrect. And all of the light is reflected back into the block. Okay, we said reflection happens not in this case, so it's not also this one. Some of light emerged into the air and some reflected back into the block. Yes, this should be the right answer. Okay. Some of the light reflected back into the block and some travels along the edge. Along the edge, this is if they are equal. This comes completely on the edge, and this is not also correct. So the answer is C. Okay. Now 35. And again, please, I remind you to know how to find here. You should know that n, the refractive index, is sine I over sine R. Okay, how to find n, or how to find I, or how to find R. And also, if you don't have I and R, and they give you the speed of light, okay, in vacuum, so speed of light in vacuum, and divided by the speed of light, but in the other medium you have, okay? So this is in vacuum. So you may use this formula instead of sine I over sine R if they give you the speed, okay? So take care about this one as well, okay? And also I need, every time I remember something. If you have, this is the normal, right? Take care, like if I tell you that this is the incident ray, so I is here. Usually we measure from the normal. Please remember, we measure I or R from the normal, okay? It's not this one. It's not this one, okay? It's a trick. Take care. Question 35. We are talking about converging lens and to obtain a magnified virtual image. And remember, the magnified virtual image happens only, okay, happens only if the object is between, like here, they give you the object, it's between F and the center of lens. This will give you the virtual magnified image. So the question here, at which labeled position is the image? They are talking here about the image. Where is the image? So the image, usually, it will be upright and behind the object. So it means the answer is A. And this will lead us to revise these ones. Okay. Look here, guys. Look, the first case. If you are at a distance more than 2f, like this, the focal length, okay? If you are more than 2 focal length, like 2f, like this one, I'm more than 2f. Here we are at f. Let's say that almost here 2f. So if you are far, you are more than 2f. So this is the first case. What will happen to the image in the right side? The image at the right side, as you see, it's real image, it's inverted, and it's smaller than the object. Okay, look, I will take the object, I'm moving to the right to be at almost 2f. So if you are at 2f, again, it's real image, it's inverted, but it's the same size, okay? If you are at a distance less than 2f, like between 2f and f, to be accurate, between 2f and f. So if you are between 2f and f, in this case, what do you notice here? That again, it's real image, it's inverted, but it's magnified, or you can say it's bigger than the object, to be clear, okay? Look, if you have at f itself, you have no image at all, okay? Look, it's became like, at f, it became like vertical line. Look, this is the case what we are talking about in this question, and the last case. If we are at a distance between f and the center of lens, or less distance less than f, what's happening here? What do you see? That the image is virtual. You see, virtual image, and it's upright, and it's magnified. It's bigger than the object. This is the case of magnifying glass. So if you ask you about magnifying glass, so you should know that the distance should be less than the focal length. For example, I may ask you, like in multiple choice, and tell you, a converging lens has a focal length 10 centimeters. Okay, so the distance from F, from the principal focus to the center of lens, is, let's say, 10 centimeters. And an object is placed 8 centimeters from the lens. Look here, it's like less than the focal length. Okay, so what would be the description or characteristics of the image? So you should know, oh, less than the focal length. So in this case, it will be virtual, magnified, and upright. Okay, guys, right? All right. Now, let's move to a new question, question 36. Okay, so what is a reason why slip rings are used in AC generator? In AC generator, why we use the slip rings? Okay, so you should know that slip rings are attached to the ends of the coil, okay, and rotates with that. Okay, but brushes are stationary; they don't move. Okay, they press like against the slip rings. So we use them actually like to maintain this electrical contact between this rotating coil and the external circuit. So you can say that the slip rings, it's connected this rotating rotating coil ends to the stationary brushes. Okay, so let's see what we have there. So the first one, to connect the brushes to the external circuit as the coil turns. Okay, next one, to connect the end, but we said that brushes are fixed, not moving. So to connect the ends of the coil to the brushes as the coil turns. Okay, this is the second one. Is that what we need? Okay. Next one, to create the magnetic field in which the coil turns. It doesn't create any magnetic field. It's not connected to the brushes. Okay. To turn the coil. No, it doesn't turn the coil. So even if you don't know the answer, you can now get the answer to connect the ends of the coil to the brushes at the coil turns. And actually, like remember, like if the coil, if it's not turning, if the slip ring is not slipping, okay, it means that these two cables, if they are not doing this, that these two cables will interfere with each other. Okay, this will create a problem for me. So I need something to rotate, okay, to like slip, okay, around. So to not make those terminals to interfere with each other. Okay, so the answer should be B. Okay, this is the correct answer. By the way, since we are talking about the slip ring in AC generator, remember also that we have in DC motor, we have split rings. Look, split rings. Okay, the split rings or the split ring commutator, because also can be a question. Okay, we use it to like reverse the connection every half turn. So to keep the current flowing in one direction, so it will not like make half turn and go back, half turn and go back. No, you will complete one full rotation, okay, or one full revolution. Okay, so take care about this. In AC generator, we have slip rings, but in DC motor, we have the split ring commutator. Okay, take care about this one. And this will lead us, yes, to talk about right hand rule and left hand rule. So it's important to know as well. So let's move to 37. A straight line wire carries a current into the page, and which diagram shows the pattern and the direction of the magnetic field around the wire. So since we are talking about current, we have only current. If it's given only one thing, which is the current, and they ask you to find the magnetic field direction. So in this case, it's only the right-hand rule, because the right-hand rule, we have only two things we have there: current and magnetic field. If they're giving you two and they ask for the third one, so it means that they are talking about the Fleming's left-hand rule. Okay, so now we need to apply the right-hand rule. So remember, right-hand here, use your right hand, please. Okay, so they said that the current into page, so it means your thumb should be goes down, like to the page. And your fingers now should be like clockwise, right? So if the current goes down, so your fingers, in this case, if you are using right-hand rule, it should go to clockwise. So it's not A, it's not B, so it's C or D. Okay, but now let's look about the magnetic field. So the magnetic field here is all of them uniform, and the distance between them, it's the same. So actually, the magnetic field, when you go far from like the center of the wire itself, it should be less. It should not be all of them to be have the same distance between them. And this is what you have here. Look, you will discover that the distance between them started to be bigger and bigger, because when you go far from the wire, it should be weaker. The magnetic field should be weaker. When you go closer, it should be stronger. Okay, so the answer should be D. Okay, the question 38. Okay, and by the way, 38 has no question about the Fleming left-hand rule, so please, you have to practice by yourself left-hand rule. To not come an exam for the first time to apply, it will be difficult for you if your first time to apply an exam. So remember that the Fleming left-hand rule, you should know that the thumb should be, this is the motion or the force, and your index should be the magnetic field. And usually the magnetic field in this magnetic bars you have, that the north and the south, you should know that the magnetic field from north to south, okay? And the third one, the middle finger, should be to the current. Okay, so if they give you you know already the magnetic field, because usually it's from north to south, and if they give you the current, you should know the force, if it's upward or downward. If you have the magnetic field like from north to south, and they give you the force, you should know the direction of current. Okay, and sometimes they may give you the current and the force, and they ask you which one is north, which one is south. So it means find the direction of the magnetic field, and you know the magnetic field from north to south, so you can know which one is north and which one is south. Okay. Now question 38. The diagram shows a coil of wire between the poles of two magnets, and the coil is connected to a direct current, DC, power supply. Which change increases the magnitude of the turning effect on the coil? Okay, we need to increase the magnitude of the turning force. So what do you think? We need to increase something, okay, to increase the turning force. So this is very important to know, because this is usually they ask this in exam. Okay, so will you decrease the number of turns? Because if you decrease number of turns, actually it's like you are decreasing the induced voltage, you are decreasing the current. Okay, so you are decreasing also, of course, the turn in the magnetic field and the turning force. So it's not decreasing. Increasing the resistance. Oh, if you decrease the resistance, you are decreasing the current. Oh, is it okay? No. Okay. So see, increasing the strength of the magnetic field. Yes, if I increase the strength of magnetic field, this will increasing magnetic field. It means increasing the turning force. Yeah. So this one is the correct answer. Reversing the direction of magnetic field. Reversing the direction of magnetic field, it will reverse the direction of that turning effect, but this will not change the magnitude. Okay. So the answer should be C. Okay. Now, 39, radioactive source that emits gamma radiation is stored safely in a wooden box with a lining. Which lining is the safest to use? Oh, this will lead us to something you have to revise very well. In radiation, you have alpha, beta, and gamma. So alpha can be stopped by a few centimeters of air or very thin paper. Okay, so it can travel like a few centimeters of air. And beta, it's few, if you want to stop it, like few millimeters of aluminium can stop beta. Gamma, you need like several centimeters of thick lead, okay, to stop it, okay, or concrete. So if you talk now about this radioactive source, with this is gamma, thick aluminum will not work, copper will not work, paper will not work. So the answer is thick lead. Okay? This one will help you. This will lead to something else. Since we have no question about this, you have to know many things actually about them. One of them, that alpha, it's positive, it has 2 protons, so it has like the charge of positive 2, and it has 2 protons, so here is 4. So if you talk about the speed is slow, like 0.5 of speed of flight. So why I'm saying this? Because this one is positive. So if you have 2 plates, they give you 2 plates, and they tell you that this one is positive and this one is negative. So alpha should be, since it's positive, should deflect. Okay, it should deflect or change direction to go to what? To go to the negative. Okay. So if you have beta and beta is -1, you have electron and it's negative. So it should go where? It should go actually to the positive, right? But gamma, since you have no charge and it has the speed of light, it should go straight with no deflection. So this is also important to know in multiple choice. And this will lead to equations. So if you have any equation, please, you have to know how to write them. So if you have alpha, you should know this 2, 4. If you have beta, you should know that it's -1, 0. You should know them, and you should know how to balance the equation. Okay, gamma nothing. The last question about an early phase of a star forms from interstellar clouds of dust and gas. Okay, so if we talk about cloud of dust and gas alone, now you are talking about nebula. Okay, if this nebula, they will have gravitational attraction, this will lead to next stage, which is protostar. Okay, so they said, what is the name of the star format? This is protostar. And this will lead to another question, that you must know the sequence of stars. Like a star like sun, the sun, our sun, It's small, medium size. So it should be nebula, protostar, main sequence star, then red giant, then white dwarf. Okay? But if it was like large, okay, star, nebula, protostar, main sequence star, okay, this is the same so far, but then it will not be supergiant, it will be red supergiant, okay, and then supernova. Okay, so the explosion of red supergiant will lead to the supernova. Supernova, till now, we are okay. So supernova. In supernova, we have two pathways. Okay, if you have very massive star, this will lead to black hole. So if you have multiple choice question and they ask you about the very massive star, so this what will lead to black hole. But if you have just massive star, this will lead to neutron star. Okay, so remember, you have to know the sequence of both of them. If you have small, medium star, or you have large star. Okay, and if you have inside the large star, if you have very large or massive star, you have two pathways. Very massive, it's for the black hole, and if it's just massive star, this will lead to neutron star. This is also important to know. Okay, and don't forget the Big Bang Theory. So you should know that the universe started from one single point, very dense point, and after this explosion, the universe still till now is expanding. The third thing to know that the age of the universe is 13.8 billions of years. Okay, so also the Big Bang Theory you should also know, because this can be a question in exam. In radioactivity, please, you should know in radioactivity also how to find the amount decayed or the amount remaining by dividing by 2. Okay, so for example, if you have 10 milligrams of any material and it became, let's say, 2 milligrams, and they ask you how many half-lives. So is 10 divided by 2, it will be 5, and then 5 divided by 2, it will be 2.5. So it means now we have 2 half-lives. Or they give you 10 and they ask you what will be the remaining amount after 2 half-lives. It will be 2.5. So this is the remaining amount. Take care, this is the remaining. Okay, if they ask you about the amount decayed, it will be 7.5. In total, they are 10. Okay, also you should know that as well. Okay, hopefully I covered everything, but please remember all formulas, revise them, and start also, for example, at the beginning you had many formulas like, let's say, the moment. You should know that the moment clockwise equals to the moment anti-clockwise. This is in case of equilibrium. Okay, so you should also solve some questions about beams if you to find the moment or to find a force. You should know also about spring, questions about spring like this one, how to find the spring constant. The resultant force of like 2 objects in different directions, you have to know something like that. Center of mass of an object, you should know as well. These cases, I explained these cases. You should know also echo. You should know if you have echo, for example, how to find the time when it arrives to someone. Electric circuits, please, electric circuits. You have to know electric circuits, if they are in parallel, like in this case, you know that 1 over R total equals to 1 over R1 plus 1 over R2. Okay, if they are in series, you add them. You should know how to find the voltage and the current. Okay, this formula, what we said about alpha, beta, and gamma. Okay, we said that also. So here, Big Bang Theory, look here also. So I mean, my recommendation for you, like after watching this video, test yourself to solve the three exams. I have here three exams I recommend of November 2025. Like paper 21, paper 22, paper 23. Like this is the three variants of paper 2 of October, November 2025. You must solve them before going the exam. It should take, if you will solve the whole paper, it should they should, like, each paper is 45 minutes if you solve all, I mean, topics. But if you solve only physics, all of them should not take 45 minutes. Okay, so search about them online, and if you need them or you need the solved paper, you can write, and I will share with you. Please study well. Okay, where is our exam? Maybe I can give you some quick notes. Please, number one, formulas, don't forget them, and usually try to write triangle for yourself to not have mistakes about this. And number two, please watch the units. Take care about units. If it's centimeter squared or meter squared, if it's Newton or it's something else. If it's energy, it's joules or kilojoules. Take care, because this units errors, it happens usually. Multiple choice, if you don't know the answer, please eliminate first to what you are sure that it's incorrect. Try to write on the paper, not just mentally to calculate, because if you write steps, it decreases mistakes, and you can see steps in front of you, and you can see your errors. Okay. What else? Take care usually about words like all, never. This stuff also, take care about it, because it's usually a trap. Okay, physics, like, it's rare to have like absolute value. Please, magnetic field, right hand rule, Fleming left hand rule. Take care about this. Difference between DC, AC, and split ring and slip ring. This stuff, have life calculations, and decay. Electromagnetic spectrum, by the way, you must know the order, like radio waves, microwaves, and you should know their order, and you should know the characteristics. For example, radio waves have like the highest wavelength, but they have low frequency. And the other side, like gamma rays, they have high frequency, but they have less wavelength. So this stuff you have to know, and all of them, they have the same speed of light. All of them are transverse. So you should know that very well. Electromagnetic spectrum, take care about this. Radiation, alpha, beta, gamma, as we mentioned. Practice, please, the three past papers, what I said, the three variants of paper 2 of March 2025. November 2025, paper 21, 22, 23. And don't forget electric circuits and the stuff. Don't forget also the density. Very, very popular question about density and volume. And the stuff, I think I have, you will find it, I think, here, like a question. Hopefully I can show you. Look, solenoid. This solenoid, for example, you can also use right-hand rule to find the direction of current. Yes, the solenoid is like the same field of magnet. Okay. The speed of light in different mediums, and speed of sounds in different mediums. So they are opposite. Take care about this. So because this, I'm asking you to solve this paper as well, because there are many important questions here. Where is not here? Maybe here. Yes, look, force and direction of force. Yeah, this one, like density, how to find the density is mass over volume. This experiment, okay, you have the mass over volume. The mass, you know the mass. How about the volume? The volume of the stone is the volume of after minus the volume before, like 80 minus 50, so it's 30. So also you have to practice this one. Hopefully this 1 hour, it was useful for you. Please like and subscribe and write comments. Thank you so much, and good luck with the last exam of science and physics. Thank you guys. Good luck. And it was honor to work with you guys. Thank you so much. Goodbye.